Alrighty folks, so today we're going to be building a sap heater. And the reason for this, I mean, it's all kind of the same thing to heat sap. There's a couple different applications. The main one is just that the efficiency of the RO, the reverse osmosis that I use to concentrate the sap, is dependent on the temperature of the sap going through it. So the colder the sap, the less efficient the RO is. You're getting fewer gallons per hour per day, however you want to put that. So if you can warm your sap up a little bit before running it through, it's going to go faster. Now, one thing that I was running into last year, which was the first year that I've done RO, is that because I don't have a indoor place to store the sap where I can keep it a little bit warmer, it limited the days that I was able to run the RO. And so basically it was, if we have a nice sunny day like today where it's a little bit warmer, I would be able to set a barrel of the sap out in the sun. With having a black tank like this, it would absorb some of that sun, the heat. It would warm it up a little bit, and then I could run it through the RO, and then I could boil after that. The problem was that the nice sunny days are also the days that I really want to be out with the evaporator and actually boiling it off. So I decided if I could make something to where I can heat the sap, then I can run the RO. If you got a kind of a crappy day, it's 20 degrees out with 20-mile-an-hour winds, I can warm the sap up, run it through the RO on those days when I don't want to be outside, and then on a nice day like today, I can actually do the boiling. In addition to that, I can also warm the sap up even higher than I would be able to just sitting the barrel out in the sun. So that should also help improve the rate that it's going through the RO and speed up that process. Now, the other thing that I'll be able to do is, if we have a cold snap like we've had here recently, and your barrels freeze up, and you get, if I can even get out of here, get chunks of stuff like this in here, that will greatly expedite getting that stuff melted back down. I've got 3 more barrels like this, where I've got some ice floating in them right now. And this is probably one of the better ones. Another one, it still has a solid core that goes from the top all the way down to the bottom. That one's just about full. So that's a 3-foot tall, and it's still probably a foot wide or so chunk of ice that has yet to get melted down. So if I have a way where I can really heat the sap up and I can break those chunks of ice down a little bit, then that'll really speed up the melting process. So for this, the barrel that I want to use is actually this one right here that I've got sap in at the moment. This one is slightly bigger than the other barrels, so I figured it's as good a one as any to turn into the sap heater. So we need to get this sap out of here. We're going to put it into this barrel over here, and then once we get this one emptied out, we can start working on turning this into a heater. So this is the pump that I was using last year with the walnuts, and this was to try and get a little bit of vacuum on the lines, and we're going to use this as a transfer pump to move the sap from here into this other barrel. Now I need to cut this one down just a little bit. So we've got, let's see, how much do I want to cut this down? I guess I do have a tape measure. I could use that, couldn't I? Alright, so we got about 5 inches between the barrel and the legs of the pump, and I want to have an inch gap in there, so we'll take off maybe 6 inches. That should get it just about all the way down to the bottom, and have an inch of gap down there so it's not, actually I guess we could just cut this side off, couldn't we? Let's see. So, I want to cut it right about the 1. Now, put that in there like that. That in here. I think I'm gonna let a little bit of this flush out of here just in case there's any junk in either one of these lines. Don't want that being saved. Now we'll see if this thing works. Alright. That in there. Set that down. Let it rip. Worked pretty well. I mean, would it be faster to use a 5-gallon bucket? Yeah, but I can set this up, let it run. I can be getting tools together for putting, you know, the heater stuff together, and I don't have to worry about doing it myself. Yeah, that did a really nice job. I like that. Cool. All right. So down here, and in this little flat section right here towards the bottom, we're going to put a hole in here, and then we're going to put a bulkhead in so that we can stick a heating element down here in the bottom of the tank. Always makes me a little bit nervous drilling holes and stuff like this, but I think this is what we want to do, I hope. Thinking about maybe doing it the rest of the way from the inside. Clean it up just a little bit. Don't need to do that, but I don't think it hurts anything. Alright, so now what we have here is a 1-inch stainless steel, 304 stainless steel bulkhead. And I hope, ooh, this is going to be tight. I'm hoping we can kind of thread this right into here. It's not quite the right size hole, but you might have to go at it with that reamer a little bit more. Man, the reverse thread on this messes me up every time I'm trying to put it together or take it apart. That might have been why I was having issues getting it threaded in here too. I bet I was turning it the wrong way. A bit more. Alright, there we go. Now, we can take this guy, put it on the inside, tighten that down. I'm dropping everything in the mud today. And that part will be good to go. Alright, so what we're going to use for heating this stuff up is just a regular old water heater element. So this is a 4,500 watt element. It's a 240 volt, so you can't just go plugging this into your normal outlet. You got to have a 240 volt for this one. But I do have that right here at the mill house where I can plug that in, so we went for one that's a little bit bigger. And this will just thread right into here. And that has a rubber gasket on it, so I don't think we're going to be needing any thread tape. Should just be able to put that right in there. Snug that down, and that should be a watertight seal. Alright, well, we've been rained out for the last day and a half, but we're gonna try and get back to this here today. Now, as you can see, did a little bit of work off camera here, and I built just a little base for this thing to set into. And the reason for that is just to kind of block off the whole bottom of this thing, because we've got that heating element in there, and you really don't want to accidentally bump up against a 240 volt connection. So figured I could try and build something small just to go around that, or just go really overkill and completely protect it and not have to worry about it. So this is what we got. I made the circle a little bit big, so I may trim these down a little bit at some point, but it's close enough. These are just sitting on here right now, and I'll probably maybe throw a screw in each corner or something just to hold it in place. But we got one more thing that I want to do to this barrel before we can start wiring it up and firing it up, and that is I'm going to add in one more bulkhead. And this one is going to have an RO push fitting connection on here, and then we'll put this down right near the bottom, and then we can run a line, probably drill a hole in here, bring it out, and then put a little valve on there, and then we can connect directly into this barrel to the RO system without having to run a line in the top or anything like that. We'll just have a permanent connection that we can hook up to, disconnect from, again, put a little valve on there, and then we'll have that set up and ready to go, and it should make it a little bit easier to pull from this tank. I think that should do it. I hope. We'll find out. Alright, now I got to rinse the plastic shavings out, and then we'll just about be ready to get going here. Alright, so we got the warmer tank over here near the mill house where we can plug stuff in. Got everything hooked up. We got our RO draw off line right there. We've got this wired in now. I went ahead and transferred a little bit of sap in here so we could do a leak test. It looks good around where the heating element is. Got a couple little drips coming out from around the RO connection, so we'll need to mess with that, but I'm not too concerned about that one for now. The main one that I wanted to check was where we got 240 volts going into there, so I think we're good with that. So I think we can now plug this in, make sure that everything's wired right and that the heating element works, and make sure that that's all good to go. And if that looks good, then we can go ahead and transfer the rest of this in, because I only put enough to cover the heating element. Transfer the rest of this in, see how it does with warming stuff up, and then I think if all that works, we can call this a success. So it's about 45 degrees. Seems a little bit warmer than I would have expected. Wow. And that looks like we're up. It kind of depends where you're pointing it, but it looks like we're up into the 60 degrees already. That is crazy. So I think, let's go ahead and, we're just going to transfer the rest of this over into there and see what happens. Still sitting right around 55 degrees. So even with pumping in another, I don't know, 20 gallons or so into there, it more or less was holding it at that same 10 degrees above where we started, while adding more 45 degree water into it. It's actually kind of impressive. So this is actually working a heck of a lot better than I thought it was going to. I mean, it's not a small heating element, it's 4,500 watts, but that warmed it up considerably faster. I mean, it was doing about a degree a minute is what it was heating it up at. So this is about halfway full, so there's 30-ish gallons in there. And in 15 or 20 minutes, it was able to take it from 45 to about 62, something around there, 60, 65. So, about a degree a minute, which is way better than I thought it was going to do. Now, I'm heading into a little bit warmer weather here, so this isn't going to be quite as crucial to have. I mean, I think it's still going to be nice that even if you got a 45 degree day, if you can take it up to 65 degrees, it should be a noticeable improvement in the flow rate that it'll go through the RO at. So it still is going to help, but like I said, kind of a big thing is just going to be if I've got chunks of ice and stuff that I need to get rid of, I can get rid of that. Or if I want to RO sap on a really cold day when I don't want to be boiling, I'll be able to warm it up, run it through, and still get decent flow rate going through the RO. So I think that's kind of it for this video, for this build. There's not a whole lot to it. It's a pretty simple device, and like I said, it actually works a lot better than I was expecting it to. I'm assuming that, you know, if I had it all the way full, it'd probably be about twice as slow, or half as fast or twice as slow for heating it up. So it might take, you know, 2 minutes to warm it up a degree, but still, that's not that bad. If you're trying to raise it 20 degrees, even if you have it full, that's only 30-40 minutes, something like that, to take it from 45 to 65 or something. So I think this thing should work pretty well for me. So that is going to be it for today's video. As always, I appreciate you guys watching, and I'll see you next time.